Okay, so this is section 9.3. We're going to start with what's just called like evaluating trig functions of any angle. Well, we already kind of did this in 9.1, but in 9.1 when we did it, if you kind of go back or you look at your homework assignments, we were working with just triangles, like geometry triangles. And so geometry triangles were just triangles out in space. They had a right angle because they were right triangles. They had some theta marked. It was an opposite, adjacent, hypotenuse. We'd label it, and we'd do SOHCAHTOA, and we could do that for any angle. We didn't even need to know what theta was. Well, we're going to do that again today, but now our pictures are going to be not the triangles from geometry, out in random space, this way, that way, whatever. We're going to have triangles that are formed by angles like we've studied in algebra: positive, negative, standard position. So the initial side is the positive x-axis. The terminal side opens up around in quadrants 1, 2, 3, or 4. So I've got a picture there. You can see my theta. I must be working with some negative angle. We could estimate what we think that angle is, but we don't know for sure what that angle is at this moment. And we don't need to know what the angle is. I've got like some circle here. I've marked this point on the circle. This is 3, -3. So that's like a point on the terminal side of my angle. That's that terminal side that opens up around the quadrants. So I'm going to give you a minute to just kind of have a quick brainstorm with your pods. Where is the triangle that we used to have when we were doing this geometrically with the triangle? So like right now we don't see a triangle, right? We see a circle with a line. So think about, where would you in your group draw a triangle? And I could think of a few different answers here. One is correct. So have a quick conversation. Where would you draw a triangle? How could you draw a triangle? Come up with a place you could draw a triangle. Where did you learn to draw your triangle? So the answer is
Where's the 90 degrees?
I think you just draw a straight line.
okay, so I'm walking around and peering over shoulders and listening to conversations and stuff. I guess I have this question. Have you done a problem like this before? No?
Probably, but I have no idea where it went.
Well, I'm pretty impressed. Almost all groups drew the correct triangle or talked about drawing the correct triangle. The correct triangle, so I have like my angle and standard position. Oops. That's okay, can move. Angle and standard position going right here. Okay, and we got this point right here at 3, -3. And so the triangle that we're going to draw is going to go back to the x-axis. So you should, from that point 3, -3, you should draw up to the x-axis. Now the other triangle that sometimes people draw is they go over to the y-axis. Could you imagine that, creating a right triangle? Okay, but that's not the triangle we want because that triangle doesn't have that central angle that we want right there. Okay, and we're going to make a rule that our triangle, imagine this if you reflect this image in all 4 quadrants, it's got to make what I call a bow tie or a butterfly. We're not allowed to make the hourglass.
Oh, I get that.
Okay, so some people are visual people, so if you're a visual kind of person, is my triangle okay? It's got to fit in a bow tie. It can't be part of an hourglass. Okay? Okay, so then if I draw that triangle, now what do I know about the triangle? It does have a right angle because we're going to draw it perpendicular to the x-axis. So we got a right angle right there. That's awesome. Liam?
And you know the two side lengths.
You know the two side lengths that are x and y, right? If your point over here is at 3, -3, how far did I go to the right? 3. And how far did I go down? 3. And we're going to call that -3. Now this is going to be the place where it's different than geometry, right? In geometry, would you have ever labeled the side of a triangle negative? No, because negative distances didn't exist. On the coordinate plane, when we've got an angle and standard position, we're allowed to label the x and the y's as negatives because they're talking about direction on the coordinate plane. So we actually want the negative there, and that's important. Okay, well, if we know the two sides are 3 and -3, what can we find? The hypotenuse, which on the circle represents what?
Radius.
The radius of the circle. Okay, so I'm going to use r. R squared equals, well, 3 squared is 9, plus -3 squared is
9.
also +9. So r squared equals 18. Square root both of those. Are there imperfect square factors of 18? 9 times 2, so we can reduce that to be 3 square root 2. Everybody on this train so far? Everybody got any questions? Okay, now one important thing to know about the radius of your circle, we are going to treat that like a geometric circle. So in a geometric circle, radius would never be negative. Okay. So when you calculate this radius around the coordinate plane will always be positive. The only things that you're allowed to label with negatives on the triangles would be the x and the y if you're going left or down. Okay. So radius is always positive. Okay, so that's going to be 3 square root 2. And now if I ask you to do the 6 trig functions, I'm going to put my 3 basic ones up here. What would you say for sine?
3 over 3 square root.
Well, what is sine normally in the ratios?
Opposite over
Opposite over
hypotenuse.
hypotenuse. Lexi?
Which angle is the one we're talking about?
The angle is marked right here. So the angle is at the, like around the origin.
So
Always.
would it be sine over h would be -3 over 3 square root 2.
Yeah, -3 over 3 square root 2. Well, okay, I am going to rationalize what also happens with -3 over 3. It's just -1, right? Okay, so I'm going to simplify that first. It's -1 over the square root of 2. And then rationalize it. It's going to be negative
1 square root 2 over 2.
negative square root 2 over 2. Okay, cool. Okay, what would you do for cosine?
It would be 3 over 3 square root 2.
3 over 3 square root 2. Bless you. Which is now a positive 1 over square root 2, which is positive square root 2 over 2. And for tangent,
3 over -3, so it would be -1.
opposite
No,
over
no,
adjacent is actually -3 over 3, right? If we want to like make sure that we're labeling things correctly. -3 over -3 says -1. And then could you do the other reciprocal? Yeah, okay, cosecant, secant, cotangent, we could flip them. If I were doing cosecant and secant, I wouldn't flip this one that I rationalized. Remember we talked about working smarter, not harder. I would rationalize this one, -1 over square root 2, because then it would just be negative square root 2, and we'll have to rationalize it again. So if I backtrack and flip it when the radical's in the denominator, then it will be in the top, and we'll have to rationalize. So that would be working smarter, not harder. Now, what we're going to see on the next slide is we're going to make this into a generalization. So this is going to happen in any of the 4 quadrants, quadrant 1, quadrant 2, quadrant 4. You guys, before you told me sine and cosine, you made me clarify where my angle was. Okay, so when we're doing these angles in standard position, you know, like that opens clockwise and opens counterclockwise, the angle that we're talking about is always right here around the origin. Okay, so it doesn't matter which quadrant we're going to be in. Okay, and we're going to make generalizations for the x and the y and the radius. What will always be sine, what will always be cosine, and what will always be tangent. So as we're writing these down, you might look back at this example and see, oh yeah, that is true. Those were the numbers that we used. So on the next slide here, we're going to write the general definition. So this is like for all points in the coordinate plane. That first statement that says let theta be an angle and stay in position, that's basically saying, think about this like we learn about in algebra, not like some random triangle in geometry. So it's just kind of giving us like the context or the lens through which we're going to look at these trig ratios. Okay, different than SOHCAHTOA, but essentially the same. And xy is a point on the terminal side of theta. So I've got this picture here. I'm going to draw an angle in standard position. Initial side on the positive x-axis, right? Terminal side, I'll just draw it somewhere in quadrant 1. And xy is a point on the terminal side, and then like if we were to swing that angle or that terminal side all the way around, then we create that circle with radius r. So we have our r. And that circle, like if you change the position of x and y, then you change the radius. It might get bigger or smaller if it moves closer or further from the origin. And remember, like we said, our angles are always happening right here, right around the origin, right? Right in this acute angle. And then if we were in quadrant 1, we would draw perpendicular to the right axis, or x-axis right there. And we would create this triangle. And the adjacent side to theta would be x, and the opposite side to theta would be y. So if you look back at the example that we just did, when we had the point 3, -3, like the way we drew our triangle in quadrant 4, wasn't that the same? The adjacent side ends up being the x, the +3, and the opposite side ends up being y, -3. And that would hold true in the other 2 quadrants. Okay, in quadrant 2, you would draw a triangle back to the x-axis, and in quadrant 4, a triangle back to the x-axis. So y is going to be opposite, x is going to be adjacent. Now, it says here r equals, Can you think of a way that we can write r for any point x and y? X squared plus y squared equals r squared. So r is r is like c in Pythagorean theorem. So what? How would you like if it's just r equals, not r squared equals? It will have to be the square root of x squared plus y squared. So I'm going to go ahead and write that down. Now, I don't care, like on that previous example, I wrote it like Pythagorean theorem, right? R squared equals x squared plus y squared. If you like writing it like that and then square rooting both sides, cool. If you want to take a shortcut, because you know it's always going to be r equals the square root of x squared plus y squared, you can take that shortcut. If you're taking algebra 3, if you're taking pre-calculus, you're going to see that r equals square root of x squared plus y squared again. And that's the distance formula. You know your old distance formula, d equals the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. Distance formula is just Pythagorean theorem. Yeah.
Why didn't they just tell us?
Why didn't they just tell us that one then?
I bet they did. I bet they did.
No.
Remember that one time you told me your teacher didn't tell you?
No, that was in my class.
Was right? Oh,
That was in my class.
That the Pythagorean theorem is the distance formula, or the distance formula is Pythagorean theorem.
Yeah.
Yeah, and the Pythagorean theorem is the equation of a circle.
What?
X squared plus y squared equals r squared. Circle. Center is 0, 0. Radius r. What? It's amazing. It's all the same thing.
Then why did we spend our time learning the other things? That's very good. Because you have to memorize one.
Okay. So if we have our triangle labeled, then what sign always going to be?
Oh, I see.
Y.
It's always going to be y over r. What's cosine?
X over
X over r every time. And tangent will always be
X over Y.
Y over X.
opposite
Oh,
over
y over
adjacent. Y over x. However, you can say x over y for
Cotangent.
cotangent. It's reciprocal. Okay, so this is very common in algebra, pre-calculus, calculus. You're going to see these more as x's, y's, and r's than like you see a triangle in geometry as opposite, hypotenuse, adjacent. However, it's all the same thing, right? So like sometimes when I'm doing this problem, you'll hear me talk about x over r. And then other times when I'm doing that same problem, I'll refer to it as adjacent over hypotenuse. It's all the same for cosine. So this is just like making a connection. Okay? And so it's like you kind of want to work on making that connection, but I get it if you go back to opposite, adjacent, and hypotenuse. You're going to get the same answer. Okay. Did you have a question?
Yeah, so R is H, Y is O, and X is A.
No matter which quadrant you draw your triangle, x is always going to be adjacent to that angle right here around the origin. Just think about that. They always go back to the x-axis, so that always becomes the adjacent side. Okay? Okay, so here's another example. This might be similar to something that you do on your homework.
Do I have to draw the circle itself? Do I actually line up the triangle?
Right. So like at this point, we have different ways that we could work this problem, and some people are going to work it differently. So this one doesn't give you a picture, right? Some people will still want to see their picture. They're very visual. I'm kind of a visual person, so I usually draw my picture. And some people are like, nope, Miss Cronkey told me sine was y over r. That's all I need to know. I got y and I got r, so I'm going to write it down. That's fine. You decide. The most important thing is that you do have to make sure your signs, S-I-G-N, positive and negative, are correct, depending on which quadrant you're in. So we're working with 8, negative 6. Okay, me being the visual person that I am, it's not going to take me long to draw a quick sketch of what 8, negative 6 looks like, right? 8 to the right, 6 down. There's my point. Can I draw my triangle now? Yeah. I know that theta is going to be right there around the origin. My right angle has to go back to the x-axis. Notice I drew a triangle that would look like part of a bow tie, not an hourglass. And this side is positive 8, and this side is negative 6. So now to do my trig ratios, I only need the hypotenuse or radius. It doesn't matter which way you say it, right? It's the same thing. It's the longest side of the triangle. Okay, well, I'm going to say r equals the square root of 8 squared is 64, and negative 6 squared is 36. That's r equals the square root of 100, which is 10. Oh my goodness, I love it when I have no radicals for my side lengths. So I have no rationalizations. Maybe just simplifying. And at this point, again, for those people who are more visual, they may still be thinking opposite over hypotenuse. Some of you maybe didn't even draw the picture. You just said that's x, that's y. Let me find r. And now I'm going to do sine theta equals y over r. Okay. I'll go ahead and up here I'll label x and y. So if you're going off the general definition we just talked about, what to do for sine y over r, that's going to be negative 6 over 10, which reduces to negative 3 over 5. And the cosine is x over r. So that's going to be 8 over 10, which is 4/5. And the tangent of theta is equal to what? Y over x. So negative 6 over 8. That's negative 3/4. Notice on this example, sine is negative, cosine is positive, tangent is negative, because sine and tangent both use y, which is negative. Look at that first example we did. That triangle was also in quadrant 4. What was the sign of sine in our first example? It was negative. What was our sign of cosine?
Positive.
It was positive. And what was our sign of tangent? It was negative. So one other pattern that you can start to see is if you're always going to the right in quadrant 4 and you're always going down, your x is always going to be positive, your y is always going to be negative, sine is always going to be negative, cosine is always going to be positive, tangent is always going to be negative. And that would change in the other 2 quadrants. Okay. Now I should do the other 6, so I'm just going to do their reciprocals, or sorry, not the other 6, the other 3. And if I've already reduced my fractions, I can just flip the reduced version. So I'm going to get negative 5/3, 5/4, and negative 4/3. Notice that partners who are reciprocals, like sine and cosecant, they're both negative. So when you flip it, you don't change the sign. Cosine and secant are both positive. Tangent and cotangent are both negative. Okay, we doing okay so far? Have I left anyone behind and you have a question for me? Leave it there? No, I must keep going. Okay, you try this one at your pods. We're going to do the point. -4, 0. going to put my visual people in a lurch because you can't draw a
0.
triangle right there, can you? No, it's on the x-axis. So if you can't draw a triangle, you're going to need to know y over r, x over r, y over x. And you and your group members find x, y, and r. Okay? Do that for me. There's no real triangle to draw. What's your radius? 4. You can see that visually, or you can do r equals the square root of 16 plus 0. You get the same answer. So tell me, what sort of interesting things are happening when you're calculating sine and cosine and tangent?
Sine is 0.
Okay, sine would be y over r, so that'd be 0 over 4, which is 0.
Wouldn't cosecant be considered undefined?
Oh, okay, so if you had 0 over 4, but then you flip it and you have 4 over 0, that's no good, right? You can't divide by 0. Never have, never will. So the reciprocal of 0 is undefined. Okay. What about cosine? Yeah, -1. The x is -4 and the radius is 4, so that's -1. What's the reciprocal of -1? -1. So secant is also -1. And then what about tangent? What is the order for tangent in the general definition?
Opposite.
Well, we don't have a picture, so we can't use opposite and adjacent. Y over x. So we will be doing 0 over -4, which is 0. And therefore, cotangent is undefined.
So if one is undefined, or 0 never has to be undefined.
Yep.
Flip it, so cotangent is 0. Tangent.
So that's something like you might write down if you feel like you need to in the margins, like the reciprocal of 0 is undefined. The reciprocal of undefined is 0. So if you're getting a 0 for one, you're going to have an undefined for another, and vice versa. They come in pairs. Now, we're going to extend that just a little bit more. We're almost done. You guys are doing a great job.
20 minutes left.
Ooh.
Like, where's 0 to x? Y.
Right, if you had 0 for x and y was a number,
Yeah.
then you're going to get the sine would be a number, the cosine would be 0, but then the tangent would be undefined. So you're going to have this undefined over here. Okay, so we use this method or this idea for something called quadrantal angles. Okay, so this is like another new piece of vocab for us, quadrantal. What word is there in quadrantal? Quadrant, yes. Quad, yes, for. Quadrant specifically. So a quadrantal angle is when the terminal side of theta lies on one of the axes. So they're basically the things that make the quadrants, right? And we know in degrees they go up by 90s. And we could reverse it, but then they'd be negative angles. And if they're in radians, they go up by pi halves.
Is that negative?
Those are all positive angles. I'm going counterclockwise. Because I'm going from 0 to the top, so I'm opening counterclockwise to the positive angle. So if you're ever asked about, like, find the 6 trig ratios of 270, well, you know 270 is quadrantal. So you're not going to be able to draw a picture of a triangle at 270. Because when you plot that point, there's nowhere to draw back to the x-axis at a 90-degree angle. So that's when you really need that general definition, y over r, x over r, y over x. Okay. But if they just give you an angle, let me see if this is an example. Oh yeah, if they just give you an angle, you're going to need some ordered pairs. You know, like on that last one, I gave you what, -4, 0? But it didn't matter what the radius or what that x value was. If we were just over there, like to the left, it could be -2, 0, it could be -3, 0, it could be -1, 0. We would have got the same results. So if you're ever asked to do trig ratios at these angles, the simplest are to use one of these 4 points. So if I don't give you the ordered pair for where the point on the terminal side is, you literally could pick any point on those axes. 1, 0, 2, 0, 3, 0, 4, 0, 10, 0, 1 million, 0. I don't care what point you pick. It's going to be easiest if you just pick something small, right? Like 1. So if you're ever asked, figure out how would you move to that quadrantal angle, right, up, left, down. And then you can use those for x and y. So I'll show you an example here at the bottom of the screen. We're going to find the 6 trig ratio for theta equals pi. Well, theta equals pi is where?
180. So
At the 180. So it's on that left side. I didn't give you a point this time. I didn't tell you -4, 0. So I'm just going to call that -1, 0. Because that would get me over there to 180 or pi. That would open up that angle. And then I have x. I have y, and what would my r be? R is always positive. R would be 1. It's just saying you went 1. And then I do the 6 trig ratios. So the sine of theta would be 0 over 1, 0. The cosine of theta would be -1 over 1, -1. The tangent of theta would be y over x, 0 over -1, 0. Cosecant would be undefined. Secant would be -1. And cotangent would be undefined. No, those are the exact same answers we got for the previous problem. Negative 4, 0. Okay, so I'm going to do a quick flip back here. Back one slide. Think about if your point negative 4, 0 is on your terminal side. Here's my initial side. Here's my terminal side. What's that angle? 180 or pi. So when we do the 6 trig ratios of theta equals pi, we should get the same because it's the same angle. It's a straight angle. It doesn't matter how big your triangles are, they always have the same values for sine, cosine, tangent if they are similar. So this one is similar to the last one. Lexi.
So if it was opposite and if it was on line y, would it just be switched? So sine would be undefined?
Well, so like let's do an example. Let's say, could I let theta equal 3 pi over 2? Are you okay with that?
3 pi 2. Wasn't that 180?
No.
270.
3 pi over 2 is 270, so it would be somewhere down here. We will call that point 0, negative 1. And what would your radius be? Don't think too hard. 1. It's positive. You went 1, right? Okay, so then if I did the sine, x, y, r, that would be y, negative 1 over 1. So that would be negative 1. So it's like the cosine of the previous one is now my sine. For the cosine of theta, that would be x over r. 0 over 1 is 0. For the tangent, I would do y over x. Well, I can't divide by 0, so it'll be undefined. Cosecant theta is negative 1. Secant theta is undefined. And cotangent theta is 0.
So if it's along that line, it'll always be that.
No, if it was up, you could have positive ones. You really just need to like do the work, right? Like pick a point, like I told you. Like so, if it's at pi over 2, then it would be 0, 1, radius 1, and these ones would be positive, not negative. So it's like don't memorize the 4 different quadrantal angles. Just know I can pick a point on that axis, and then I can find the x, y, and the r. That's the best way to do it. Okay. Okay. Good questions. We won't do that one since we did that extra one. Here's your homework assignment. For Wednesday, I will see you.
Oh yeah. 2 days to do it.